Alright, so we're going to estimate the impulse on kind of a difficult graph to find the area. Here's our question. Suppose a force acting on a tennis ball is represented in the graph. Estimate the impulse on the ball. So I need the area under this curve, but it's not easy to divide up into rectangles and triangles. So what I'm going to do is, first, I want to figure out the impulse of every one of these boxes, and then I'm just going to try to count boxes as best I can. So first I need to know the width of the box, and here I see that from 0 to 1, 2, 3, 4, 5 spaces is 0.01 seconds. So to find the width of each box on the x-axis, I need to divide that by 5, and I find out that the width of each box is 0.002 seconds. So that's how wide this box is right here. And over here on the y-axis, from 0 to 100 is 2 boxes, so the height of the box is 50 newtons. So what I want is the impulse per box, and that would be force, 50 newtons, because impulse is force times time, times 0.002 seconds per box. And I will find that my impulse is 0.1 newton seconds per box. So now I just need to know how many boxes it is, and then I'll multiply this number by the number of boxes. Well, I've got 1, 2, 3, 4 definite boxes, full boxes. And then I think that these down here are very close to a full box. What I'm going to do is try to see if there's like a little piece somewhere that would make those a full box. And I see a very tiny piece here and one here. So I'm going to take these two at the bottom and add it to these two little slivers at the top and say that gives me 2 more full boxes. And then I think right here, each of these is probably about half a box, so that's 1 more full box. Down here at the bottom, I don't think those are quite half a box. I'm just going to make it up. Maybe like together they give me 0.8 of a box, not quite a whole box together. Then right here, I think if I took this and added it to this part from up here, that would be a whole box. Same thing here, take this part, add it to this little bit here, that's a whole box, that's another 2. And then I think up here I've got almost 1 more whole box, but not quite, so I'm just going to call it 0.9. I'm just estimating. So that's 4 plus 2 is 5, plus 1 is 6, plus 2 is 8, plus 0.8 is 8.8, plus 0.9, 9.7 total boxes, I do believe. Sorry, right after I paused the video, I realized I'd made a mistake adding. So let's cross that out. 4 plus 2 is 6, plus 1 is 7, plus 2 is 9, plus 0.8 is 9.8, plus 0.9 is 10.7. So about 10.7 boxes. And then I've just got to multiply this, 10.7 boxes, and I get about 1.07 Newton seconds. Now, probably usually be faced with a little easier than that, just split it up into triangles and rectangles, but if the evil testing serpent who makes the AP exam feeling particularly persnickety that day, they might give you a crazy one like this, where you just gotta estimate your best and then pick the answer closest to it. And that's it. See you tomorrow.